Okay, we're also recording, so. Alrighty, and people start to come in. Hello out there, everybody. Welcome to another month of CSINext. And we're gonna give people a few minutes as they trickle in. We've got a great presentation today from our very own Mark Ogg, who's going to talk about COVID and indoor air quality, which is something that I think we're all very aware of and very concerned about at this point in time. So I hope everybody is having a really good late summer and early fall. Although, frankly, we're getting weather in below freezing at night where I am. So it's fall is rapidly heading into winter in the northern parts of the country. Anyway, I see Daniel, I see Ann Baker, I see Thad, I see George, Jeff, Michael. Excellent. Welcome, everybody. It's going to be a great presentation. So I'm just going to give people a few more minutes. I'm going to start doing something a little different with our meetings as we get going. I'm going to now anyway, I'd like to start each meeting out with a call out to some of our members that have done something extraordinary. Awards that people have won, fellowships that have been awarded. This month, I want to highlight the Construction Specifier Article of the Year Award that was given out at the CSI convention. Two of our very own CSINext members, Chris Bennett, our president-elect, and Keith Robinson, a member and former board member, we're on this group that wrote the award-winning article for the construction specifier, Filling the Voids, Differentiating Between Concrete Coating and Polishing, a great article in the construction specifier. And they're very they're very knowledgeable, and it's a great article, as well as the fact that Keith is going to give our presentation in December, talking about, again, bridging the gap between Division 3 and Division 9, and how to deal with those kind of things. So that's something to look forward to. But I'd like to start highlighting what our members are doing. So if you've received an award, if somebody that you know that's in the chapter has received an award, shoot it over to me. I'd love to basically highlight them in front, one a month in front of the chapter meetings, and just give us a chance to recognize each other a little bit more. So in the meanwhile, I hope everybody is doing fantastic. So I'll sort of soft pedal a little bit here. Thank you all for coming. Next month's presentation is going to be Innovative Cement Board Applications by our very own Thad Goodman with National Gypsum. And that should be a great presentation, because I think we all end up using cement board at one point or other. I know it's always a point of confusion, and too often tries to get value engineered out of the project. But I'll give people a few more minutes to trickle in, because let's see. We're up to 8 folks. So welcome, everybody. Welcome, welcome, welcome. Again, just highlighting our very own Chris Bennett and Keith Robinson, that were part of the team that won the Construction Specifier Article of the Year. So bravo to them, and good job, very well done. And this is a great article. And I think you could probably get the little QR code right off the screen if you wanted to pull up the article and read it. All right. Give us one more minute here, and then I'm going to throw it over to my good buddy, Mark Ogg, who is a board member and is going to talk to us about a really pertinent and interesting subject. Mark, are you all ready to go when I throw it to you?
I'm ready to go.
All right. Excellent. Let's give it about another minute and let people kind of trickle in. We're going to keep the questions to the end of Mark's presentation, but if during the presentation you have comments, questions, anything that comes up, please throw them in the chat, throw them in the Q&A, and I will keep track of them and make sure of the meeting. Do have an item in the chat from Thad Goodman. Many thanks to Mark Ogg for presenting to the CSI Columbus chapter meeting this past Monday on gamification. Well presented, and the chapter members in the room really enjoyed it very much. So thank you very much for that, Mark.
It was a lot of fun. Fortunately, I was going to try to get there, but duty called in the morning and I wasn't able to get out of the office. But I know it had a lot of good questions, a lot of good discussions, and I'm glad they enjoyed it.
Good. Excellent. All right. Well, we are at about 5 after. So that being said, Mark, I think I'm going to throw it to you.
Okay.
And Mark's going to do his own introduction because not that he thinks I don't like him, but he's got his whole spiel recommended, organized. So Mark, please take it away. And I'm going to mute myself. And again, put your questions in the chat or the Q&A. I'm going to hold them to the end, and we'll get them all responded to then. All right, Mark, have at it.
Great. Thanks, Catherine. Hello, everybody. Welcome to the October CSINext chapter meeting. I'm Mark Ogg, your presenter for today, and we're going to be talking about designing for indoor air quality and COVID-19 mitigation. Now, I know we're all tired of hearing COVID-19, so I'll try not to say COVID-19 much more than what I already have. So a little background on myself. Been a construction project manager and a consultant for 27 years. I've been in the commercial, industrial, life sciences, R&D and manufacturing construction worlds. Have a bachelor's in construction management from the University of Cincinnati, master's in construction management from Western Carolina University. I'm professionally affiliated with CSINext. As you can see there, I'm currently the treasurer of this chapter. I serve on the CSI editorial advisory committee for the Construction Specifier magazine, and currently serve on the CSI certification committee specific to the CCCA content. I'm also a member of the Project Management Institute, and I have both my CDT and my CCCA, as well as my PMP and both my OSHA certifications in general industry and 30-hour construction disciplines. So what did I do here? I went the wrong way. There we go. Okay, back on it now. So we're going to talk a little bit today about indoor air quality. So let's talk about what IAQ is and why is it important. So I think most of us know that IAQ stands for indoor air quality. Very important component of facility design. The ASHRAE definition, and ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. They have a lot of design standards for climate control. I think we all know that we pretty much design our facilities to those standards within the climate zone that we're in, and we'll take a look at those a little bit later on. But indoor air quality, as it is defined by ASHRAE, is the air quality within and around buildings and structures as it relates to the health and comfort of its building's occupancy or occupants. And the one reason, 3 reasons here that IAQ is important. When you think about it, 90% of our time is spent indoors. And I got to thinking about that, and I did a little bit of multiplication, division, a little calculating, and I figured, if I spend just a few hours a day outside doing something else, I came up with about 75–80% of my time is spent indoors. So the 90% is probably not far off. But when you think about that, we spend a lot of our time indoors. We usually eat, sleep indoors in our homes. We are indoors at our places of employment, some of which are our homes now. Some of us go into offices, but a lot of our day is spent somewhere indoors. So about 90% of a person's time is spent indoors, and 2 to 5 times more pollution and nasty particles are indoor versus outdoor. And another aspect of having good indoor air quality and the importance of it is the impact of COVID-19. And I don't think I need to go into all the gory details of how this stuff spreads and how bad it's spread and what we've been living with for what will almost be 2 years here coming up just after the start of 2022. But OSHRA's official position on IAQ in their documentation is this is an essential building service, and that all decisions about buildings, heating, cooling, and other systems must consider the implications for indoor air quality. So OSHRA, in addition to their standards and guidance on designing facilities and what we need to account for in climate control and climate conditions, and being able to design proper ventilation, heating, and cooling systems, they are now also considering this an essential building service, and it means it is probably at a higher focus. Not that it hasn't been in the past, but this is first and foremost on everybody's radar now, especially with the impact of COVID. So let's talk a little bit about how particles are spread throughout the air and how they affect the indoor air quality of our facilities. So there's pretty much 4 basic methods of how we spread particles in the air. We cough, we laugh, we sneeze, and just down here on the right side talking. I mean, that's an everyday occurrence with most people, whether we're talking on the phone, talking to other colleagues at the office. If you've had a long, crazy day, you might even be talking to yourself, who knows? But those are 4 different, the main methods of how we spread particles throughout the air just from ourselves. Indoor conditions and contributing factors to that. I want to jump back real quick here. Even though that these are all natural things that we do, we're putting this stuff into the air in our facilities. Our facilities with their ventilation systems, and even though we have some outside air coming in and it mixes with the produced air from air handlers and stuff, as we put this stuff in the air, it returns into the system. So it is filtered, it is returned into the system, and it's put back through the system, and we're hoping that filters and such are doing their jobs. But really, if we're spreading stuff around on the inside of the building, it's getting distributed throughout that building, throughout the ductwork and the ventilation systems that are currently intact. So indoor air conditioners, there's 2 really main conditions that contribute to spreading particles within a facility. And that is they can each stand alone, or they can be combined. And those 2 contributing factors are cold air and dry air. With cold air, I know that most of our facilities are designed for between 72 and 74 degrees, I think, on standard. But as air gets colder, the temperature will drop. The humidity levels inside buildings drop as the air gets colder. Sometimes facilities are set to kick back to mid 60s when they're not occupied, and then they reheat on whatever their automation system has them coming up to when they're in occupied mode. But as that air gets colder, that humidity level will drop. Also, the density of the air will drop too. It will be maybe a little thinner. And that comes into play here as we get down the road and talk about a few things. Moving over to dry air, if you got dry air, you don't have a whole lot of moisture in an environment inside a facility to begin with. You'll notice that you get skin irritations. Maybe your skin gets dry, you get a little scratchy, you get an itchy nose, sneezing. Dry air will cause people to sneeze. I can attest to that. Sometimes I get on sneezing fits if I'm in a facility that is maybe a little bit too much on the dry side, doesn't have a lot of moisture being introduced into the air. And dry air also gives us throat irritations and then gives us coughing fits. So when you combine these two, if you combine a temperature drop and lower humidity, you got people that are sneezing and they're coughing. Well, with the thinner air in there, this stuff's gonna be spreading everywhere. So with facilities that do not have humidification introduced to them, your typical indoor air conditions are you're gonna have cooler air, you're gonna have drier air, and that is a breeding ground for things to just naturally spread through the air. So like when you hear people, everybody in the office, somebody gets a cold and the next person has a cold, the next thing you know, half the office has got a cold, can be contributed to the condition of the air in the facility. Maybe it's a little too cool, there's not a lot of humidity, it's dry, it's allowing this stuff to just spread around and recirculate around and redistribute itself all over the place. Contributing factors like particle spread. This allows particles to spread faster. Thinking of like a football game, you got a punter, they talk about having hang time. It's the same thing. If somebody exhales these particles, if the air is not heavy, if it is light in nature, that stuff it throws it out there and it just hangs there. This increases the risk of exposure on three different levels. You can have person to person, you can sit here and talk, you can sneeze, particles will go through the air, you can transmit stuff person to person, you can transmit person to surface, coughing, sneezing, just general talking, just exhaling particles from your body as you breathe and talk can get on surface. And then we also have what I call the person to facility infrastructure transmission, which again is this stuff gets into the air system, it gets into the return ducts, just makes its way through the climate control system within the facility itself. And what has been found is that viruses, they stay stable longer and find our airways better when the relative humidity sits at what they call wintry levels. And usually I live here in the Midwest, and I know we can get some pretty cold spells in the winter. When they're talking wintry level humidity, we're talking well below 35%, sometimes around 30. I've even seen some facilities get into the high 20s percentage-wise on relative humidity, and you can feel it. When you walk into a space that's dry, you can really feel it's dry. You get the itchy throat, you get the dry skin, you get the little persistent cough. So as we look at how particles spread, how they can spread, what causes them to spread, we start looking at humidity levels. And ASHRAE, along with the EPA and CDC, have been doing they've been doing research on this for a while, but especially within the last year or so with the pandemic and such, there has been discussion on recommended levels of humidity for facilities to help improve indoor air quality and help improve the decrease in how things are spread throughout the air. So, ASHRAE, as I think we all know, is divided up into climate zones. There's several of them here. I believe there's 8. Looking at this, I did have another diagram I was going to share, but it was way too busy for a PowerPoint slide. But each one of these climate zones is what we are required to design to mechanically within our respective locales. And you get over here on the West Coast, you've got some moist air, you've got moist conditions, cold conditions, you've got dry and hot conditions. Here where Mr. Goodman and myself live here in Ohio, we are a plethora of conditions. We can have hot, dry, cold, wet. We can have all that in one day. So it's really a challenge in some areas of the country to design for indoor climate conditions and work to maintain that level of control and provide a good environment that's maybe not too dry. You definitely don't want one that's too moist. That gets into some problems we'll talk about down the road. But the EPA, if you look at EPA and OSHRA, the EPA in general recommends that 30 to 60% relative humidity in an indoor environment. That the EPA they're more focused on mold. And I've been in facilities that have mold, and I'll tell you what, it's not fun. And OSHRA, in the OSHRA handbook, chapter 22, HVAC and equipment, they recommend maintaining above 30%. So you have the EPA that's saying, okay, well, we recommend 30 to 60% relative humidity within facilities to, help combat the growth of mold and moisture growing substances. And then we have OSHRA saying, okay, well, we recommend maintaining above 30% for air quality. OSHRA has come out with a position, it is called the OSHRA position document on infectious aerosols. That is an entire read and presentation within itself. I did do some reading on it. It's very scientific, probably a little bit too scientific for my like, but there is some good information in there on how particles spread and things that are being looked at and done to being controlled. They also make reference in there to CDC recommendations. So they've combined all three of these and they come up with a happy medium. And OSHRA's official position on infectious aerosols and their spread, they are recommending that facilities now be designed to maintain 40% to 60% relative humidity. Now that's a range. I've been in facilities that have had upwards of 60% humidity, a little bit too wet for my liking. But here in Ohio, like right now, most facilities here, even if they don't have humidification introduced to them, just because of the weather we're having currently at the time, we're at about 55% on a natural basis. Now, as we get into the colder months here, starting in November, December, January, that's going to drop down. The temperatures start getting into the 20s and the 30s. We're going to drop down to 35, 30%, some places even less than that, depending on how well your facility is constructed. But within the last couple of years, OSHRA has said, hey, look, we recommend 40 to 60%. We recommend it because it complies with the EPA's recommendation of 30 to 60% for mold, and it covers our recommended 30% humidity for HVAC and equipment to maintain in facilities. So as humidification is added, this is one of our little favorite diagrams here. I think we're probably all sick of seeing this 6 feet thing within the last couple of years, but airborne spread is covered here. As you can see, particles flying through the air. As humidification is increased, that droplet spread greatly reduces itself. Now, I'm not going to get into the whole 1 foot, 2 foot, 6 foot thing. We can talk that till nauseum, but the basic premise is that the more moisture there is in the air, the less propensity there is for particles to just spread at a high rate and endanger other people of becoming infected with whatever may be floating in the air, whether it's flu, it's the common cold, whatever it may be. So we're going to talk about a few options for introducing the recommended humidification levels. So now that we kind of understand, okay, how things are spread, conditions that affect the spread of particles in the air, there's a few options that have been put into practice and introducing recommended humidification levels into facilities. We're going to cover three, and I have direct experience with one of these. Two I've looked into and done a little research on myself. And then down the road here, we're going to talk about a case study of a project that I was involved with that actually introduced humidification into a facility that was fairly low. And we'll talk about the results of that. But the first most common way of putting humidification into facilities is a method that is called direct steam injection. And if you look down here on the left, this is this particular piece of equipment here is made by Dry Steam. It's essentially called a direct steam injection humidifier. It's a series of tubes and nozzles that are cut into the duct, not far from the fan, and sprays the humidity into the duct, which is then carried throughout the facility. Dry Steam is just one of the many vendors out there that does this. This was the one I had the most product information currently available on. These type of systems are primarily located in ductwork. You definitely don't want one of these sitting on your office wall spraying water into your office, but this is mainly a duct location installation. Requirements for these, excuse me, are you must have steam service. Obviously, it's a direct steam injection unit. If you don't have a steam service, you're not going to be able to inject steam very easily. And you must have the ability to produce the steam at the capacity that is required. Accessibility. Not so much from an ADA standpoint, but from a facility accessibility standpoint of being able to get these installed in the correct location in the ductwork. If it is an existing facility, if it is a newly designed facility, it's a lot easier to design in that location and make sure that facility folks can have the access they need to get to these areas safely to help maintain and perform preventative maintenance on these units. And then also having a sufficient building automation controls system. This is not something that you just stick in there and flip the switch and let it go. It can be very temperamental, and it needs to be pretty much fine-tuned, because the last thing you want is to what we call make it rain in the building. You can really soak some stuff down pretty bad if you're not careful with the application. Advantages to direct steam injection: low maintenance. Preventive maintenance on these systems is usually a once-a-year check, clean the nozzles, check for clogs, everything. Since it is tied into a building automation control system, there's a lot of data to be trended. You can see when the equipment is operating optimally or when it is not. And maintenance to these is pretty low. It's a fairly simple installation. Installation in anything that is an existing facility, it's going to be difficult no matter which way you go about it. But when you look at the complexity of some of the stuff that is on the market, this is pretty much a simple installation. These holes are cut into the ductwork. The tubes and the units are put in, connected, steam's piped up to it, controls are put to it, and off you go. A couple disadvantages to this direct steam injection: energy consumption. I mean, you are producing steam, so you have boilers and chillers and condensate pumps and returns and drains. You've got all kinds of stuff that's sucking energy. So it is a little more energy consumption, energy cost wise. But I think, facilities are starting to see that their employees health and well-being probably far outweighs a little bump in the utility bill. Another disadvantage to this is you really need to make sure that your boiler treatment additives are compatible with the materials that these are made out of, and that those treatment additives are being applied in the right dosage. You can go both ways with that. You can go too much and you can go not enough. It's really important to be right on the money with that. Another type of application is what is called the centrifugal atomizing humidifier. And this is essentially just a fan that you can put this direct in the local space, or you could put it in the ductwork. Most applications I have seen with these are in ductwork applications. This is essentially a fan that is in the ductwork. It has a shroud, it has a motor, it's got your control cables to it. There is a water inlet valve at the bottom, and then this fan is controlled to blow when humidity is needed. It is fed water, and it sprays it into the ductwork system, much like the direct steam injection, moves it throughout the system and humidifies the space. Requirements for this type of system: domestic, deionized, RO water. As long as you've got water, you can make this work. Again, accessibility, existing facilities, making sure that you have this in the right spot in the duct and it can be accessed and made for maintaining it. Any repairs that may need to be done to it, that is a key thing. Again, if you're designing a new facility from the ground up, those locations hopefully are going to be considered for ease of access. Advantages, again, this is another one. It has fairly low maintenance, not really too much to do to it, other than do the yearly or bi-yearly inspections, electrical. Make sure you don't have any clogs, check the water quality. It's a fairly low install cost. Again, we are just putting these in the duct. I don't mean to make light of how easy it is. I've seen systems like these put in, and they can get pretty complicated installation wise, especially in existing facilities. But overall, it is a fairly low installation cost, even if you're retrofitting. Very low energy consumption with these. You're not having a lot of pressurized steam. There's not the utility drag on the boilers, chillers, and condensate pumps. Pretty low energy consumption. Majority of these fans, I believe, are as low as 120 volt. Couple disadvantages: quantity required versus something like the steam injection, where you have a set amount of steam and you can raise that up or down as needed. These may need a lot of fans depending on how big your facility is. So there can be a lot of these. That's a lot of extra things you got to pay attention to. The installation environment, these are mainly used in, I'm just going to say, basic commercial office spaces. You don't really see these types of applications in a high-tech environment, especially anything that is extremely tight on temperature and humidity control or a combination thereof. Another disadvantage to this is, drain locations. These do require a drain, so you will need to have some drain piping, and drain piping can get fun, especially in existing facilities. You need to make sure you have enough length, enough fall. You're going to be able to exit excess water and drainage quickly and safely. And anytime you're dealing with drains in an interior fashion, it can get complicated, especially if you have leaks. But overall, they're a very, very effective system. The third type of application that is starting to come into the fold is what they call the rigid wetted media humidifier. And this is a bank of filters. much like your humidification pad there at your house, where water is introduced to these filters, the air comes across, carries the moisture with it as it goes through the system. These are primarily located in ductwork. This is definitely not something you would see sitting out on the floor somewhere. This is going to be located high up in your ductwork, up in the air handlers on a mechanical mezzanine. They are fairly sizable. You see a lot of these in large applications such as manufacturing facilities, R&D facilities, things of that nature. Requirements for this, you need to definitely make sure you have enough domestic DI or RO water capacity. Again, accessibility to be able to maintain and take care of these is of utmost importance. Fairly low install cost and fairly low energy consumption. The disadvantages to this, and I know I just mentioned the install cost, was actually an advantage. More of an advantage in a new facility than it is an existing one, because these can get fairly sizable. If you're in an existing facility, an older facility, space probably is not at a premium. And then again, the drains and the flushing, you are using a tremendous amount of water. You need to make sure that there's proper drainage, proper fall, and then that the quality of the water itself is good. You use these on hard water systems, you're probably going to have some type of clogging or calcium buildup over time. They work wonderful. I'm a little just adverse as to spraying water on something and then blowing it with a fan, but that's just me. I have seen a couple of these in use, and engineered and designed properly, they do a very, very good job. So those are three applications that are in the market now. The direct steam injection, the centrifugal atomization, and the rigid wetted media type humidifier. So I mentioned earlier on that we were going to look at a case study. And the project that I was involved with, I'm still involved with it because we're not quite done yet, is a direct steam injection application. And we'll go through what the application was, what the basis of design was, a few of the results that we've had from the systems getting up and running, and then most importantly, lessons learned and future learnings for future applications, which has been very, very helpful in other places that I have been involved with putting these in. So really, it was an interior office direct steam injection application. It was here in the Midwest. It crossed multiple facilities for the same client. Total of over about 750,000 square feet of commercial office here in the Midwest. This was the request of the client's corporate strategy to mitigate the spread of COVID-19 within their existing facilities. A lot of these facilities are older. A couple of them are newer, but they don't have anything beyond natural humidification that's brought into the space. So we were going to have to add humidification. The requirement was we maintain at least a 40% RH level. Not a problem during summer months. Believe me, we're dehumidifying if anything. But come November through February, we do drop down into that high 20, mid 30% range here, which we talked earlier, crosses into the zone where things are spread, infectious things are spread through the air fairly rapidly. So design basis feasibility studies, engineers came back with the recommendation that the direct steam injection application was the best option. The reason for that was because all of these facilities, with the exception of one, which we'll get to, had steam capability. And so we would be able to use the existing steam capability. The capacity was there for it. That was going to be the best application. Our project delivery method that we used on this, we used the integrated project delivery method. to perform this project. So we brought the engineers, the construction managers, and the trade partners in early. They helped with the design because they're very familiar with the facilities. Especially some of these facilities are dating back at least 50 years. So they were very astute with accesses to areas, what could be done, where we can install things, and just overall knowledge of the grounds and the facilities was pretty important. Some of the project constraints that we faced during this, during construction, the facility was occupied. Again, it wasn't a full occupancy, but we still did have people coming in and out of the facilities on a fairly regular basis. Some of these facilities had manufacturing operations going on. Some of them had labs, so there were a lot of people coming in and out. We were mainly focused on the office areas. Those were the only areas that we focused with putting humidification on, because most of the other areas required it for the operations that they had in there already. Access to the mechanical infrastructure, that was a fairly large constraint. As I mentioned, these facilities were not old, but they were definitely not built within the last 20 years. So getting above ceilings, getting around structure, getting around existing utilities and things that have been added over the year presented a very, very unique challenge. Some of this ductwork that serves the areas is very large stuff, up to 48-inch square duct in some areas, just because there's a lot of air that needs to move through these facilities. And there also was a couple concerns at a few of the sites with current capacity of the utility systems and the actual availability of the steam service, if we would even be able to get it to where we needed to go. So what we installed, there were 11 locations across the city. We put in 47 direct steam injection units, very similar to what I showed you in the picture there before, the little 4-tube. Well, that was most of ours were 4 tubes because this duct was just enormous where we needed to put them in. 47 direct steam injection units. We needed to put in 15 electric steam generators. Excuse me. A couple areas were not able to get the steam capacity as we originally thought. A couple areas, actually, a couple facilities did not have steam generation as a source of availability at all. So we needed to bring in a steam generator to make the steam, which was a structure mounted unit not far from the unit itself, that would direct, pulls off domestic water, makes the steam, shoots it to the dispersion tubes, and out it goes through the duct. Multiple control valves and actuators. The reason I mention this is because there was a ton of these things, and again, access and just overall accessibility to being able to have room for actuators to be able to operate. Huge challenge, especially with a ceiling that is packed with a lot of process pipe, electrical conduit, air piping, you name it, it's in this ceiling. Insulation and heat tracing, very technically difficult work, especially up in the spaces. Your insulation, if we're running a 1-inch steam line, well, we've got about 3 to 4 inches of insulation on the outside of it because it's double that pipe. Trying to find that space, design for that space, was a very difficult endeavor at times. Building automation controls, each site had a little bit different control system, which made things challenging. Some versions of the control system were newer than the other. A couple of facilities that were purchased by the client instead of built by them early on had completely different control systems that we needed to go through and figure out how we were going to make this work. And then at the completion of the installation, we did a full, was mainly what I call a CQV, a checkout, a qualification, and a verification that this would work. We did not do a fully enhanced commissioning. but we did do a pretty intensive checkout and testing of the system. So the successes that we had from the direct steam injection, commissioning test verified the compliance within the operational limits. And unfortunately, I'm not able to show you that test report because it's got some client information that I am confidentially bound that I cannot divulge. But we ran the first two systems that were up, we ran for a week solid, 24/7. Prior to that, we measured humidity levels that were between the 30 and 35% on average. We never dipped below 40% with the system in operation. We stayed right at that 40-41% level pretty consistently. We found that there was very minimal impact to current infrastructure loads. The sustainability group within the client's organization was concerned about, okay, understand why we're doing this, but what are we going to look at? What are we looking at as far as impact to our operating cost and our sustainability initiatives? We're trying to consume energy and use renewables and things of that nature. Very good news to report that the overall energy consumption, the load on the boilers, electric consumed from condensate pumps, etc., very, very minimal. In fact, I don't even think it was really a blip on their overall radar, which is good, because anytime you're using steam loaded or steam operated equipment, you really run the risk of increasing that cost. Excuse me. The learning curve from start to finish of the installation, first couple sites were a little bit difficult, but overall, because we were using the IPD delivery method and there was that constant owner, architect, construction manager interaction through those weekly meetings, we were able to reduce the learning curve overall, and we saved roughly about 10% on over installation cost, which actually helped us out because we did have a few hiccups here and there, and those savings were able to be applied to help offset the cost with some difficulties that we ran into. So what did we learn from this? Well, I've got most of the facilities are complete, but there were several areas that we learned where we could do better, and things that we would have done, things that we shouldn't have done. The first area where we learned a lot was our specifications. As I mentioned, we did this with a IPD delivery method. And I think one area where we could have done things differently was in the area of our specs. I think we went too deep. And when I say we, I'm talking the client and our engineering team went too deep on specifying exactly what we needed. And in turn, I think we would have used the IP, maybe had more of a narrative or descriptive, maybe a more performance-based specifications with our HVAC and contractors when we bought the equipment. I think we could have alleviated some of the issues we had. We had just wrong sizes of stuff that we didn't really do a good job of ascertaining. Had a couple that just weren't going to work because we, asked for the wrong stuff. So I think with the specs, we would have done a little bit different, done a more narrative, a more performance-based application with those. Actual productivity versus estimated. When we put together our ROM estimate, one area where we really did not do a good job was understanding the productivity factors for the environment that we were going to be working in. Even though that we worked in these facilities for years, we did not really take a hard look, or we probably talked ourselves out of a lot of what we did not like what we were seeing at first, cost-wise. And that impacted us negatively. But again, we were able to have some cost savings to help offset some of that stuff. But understanding the difficulty of working in the environment that we were working in versus what it actually took to do. Having to do it again, we would definitely increase those factors. Impact of the facility residents during construction. I can tell you if anybody takes this on in their facilities, get ready for some noise. There's a lot of cutting, a lot of banging, and a lot of beating that goes on, and it's well worth it because it works. But we probably should have done a little bit more of this main installation work, maybe off hours. It's not the most opportune thing to do. You don't like to ask people to work off hours and weekends and that type of stuff. But many times we were just making too much noise. We were making too much vibration. People and processes were getting upset. Next thing, control system capability or compatibility. That is a huge learning right there. A lot of these newer systems are very technologically advanced. Sometimes they do too much. If the control system's older, it may not be able to communicate effectively or at all. Ran into a few situations where we had to make some serious modifications. So I would recommend doing a full investigation of whatever building automation control system, if there is any, be done, and make sure that any equipment spec, especially voltage wise and operationally and sequence of operation wise, is compatible with what needs to operate, how it needs to operate, and how it needs to be monitored and alarmed. Building components functionality with humidity. This was a very big one. As I mentioned, the facilities were a little small or a little old. And some of those components, drywall, ceilings, doors, they don't react well to increased moisture in the air. So we did find that facilities that had a lot of metal in them, a little bit of surface rust here with the increased levels over time, and especially probably the biggest thing we've seen is swelling of components, especially wood doors. Closing, opening, getting stuck. New facilities, great, you can design that stuff in. Older facilities, you need to take a look at what you have and what the effects may be on that. We're getting through it. We fixed a lot of doors, but we're getting there. And then the last big lesson we learned was that when you put these in a direct steam injection, it is a very violent spray of stuff. It's not a lot, but it is carried by air, it is carried by fan, and these moisture droplets are going down the duct as they disperse into the space. Any type of detector, be it a smoke detector, temperature sensor, airflow sensor, anything that you have that is going to be in the path of that direct spray right as it comes into the duct, needs to be looked at closely. Either if it needs to be, do we really need this here? Can we take it out? If we do, where can we relocate it? We have ran into many issues where sensors were set off of various types because they had just moisture coming by them and they thought something was there. So making sure that the control components are spaced away from that wetted distance, as they call it, and verifying that distance can be designed in and maintained is huge. So those were a few of the lessons that we learned from this application. That was, like I said, this is the only one of the three that I've actually done. But overall, we have found that humidity levels within the facilities have been able to be maintained at higher levels. Knock on wood, their client has not had any COVID outbreaks, and I would like to say that's all because of the increased humidification, but I hope that it's just because of other factors here and things are finally starting to get better. But that's in some indoor air quality design considerations and some applications. So with that, I will wrap my presentation up. Thank you for attending today, and I will be more than happy to answer any questions.
All right, Mark, thank you so much.
We do have a question from Daniel who wants to know, are these affected by climate? And I happen to know that he's in Arizona, which is a lot drier than where you are in Ohio.
Oh, I knew he was going to ask that.
Can you speak to that in any way?
Well, the the drier, I haven't had much experience with applying humidifications in climates like where Daniel is, because I know where he lives out in Arizona, it is very, very dry. Is the question, will these work in that environment? Because yes, they will. It is just you're going to have to pump a lot in there, and I think when you pump a lot in into the area, you run the risk of oversaturating. I know the manufacturer we worked with was doing some work out west. I don't know if it's out in the Arizona end. I think it may have been out in California. But I do know that humidification will work in a drier environment. It just takes a little bit more humidification, a little bit more moisture to get it in there. I would think in an environment like that, the direct steam injection would be the way to go, because you can control the amount of, you can generate as much steam as you want, and then just either when they set the tubes, they increase it, decrease it.
It sounds like at that point, if you've got a climate conditions that are really extreme, you definitely want to be working with the manufacturer and have your engineer making sure that he's checking everything, and you'll want to know how that's going to affect your ductwork and your sensors and your supports and everything. Right. So it just kind of, it's the same thing you have to be aware of if you're working in Florida, except that humidity is there all the time.
Right.
So,
right. And like down in Florida, you're probably doing more dehumidification than you are humidification.
Right. That's pretty much what we've got in the questions. We are about 4 minutes to the hour. So if anybody else has any questions they want to throw into the chat, throw into the Q&A. I'm going to say thank you, Mark. That was a really great presentation and very interesting. Humidity is always an issue. And the thing about humidity is it doesn't have anything to do with airflow. Humidity spread is not governed by airflow.
I would just make sure you have enough airflow to move it, because if you let it sit in there, you're going to have a problem.
Yep. It's anytime you introduce water to an environment, whether it's intentional or unintentional, you need to take some thought and figure out what it's going to do. Yep. So that is this month's presentation. So please, everybody, keep your eye on your email, because next month we're going to come back and talk about innovative cement board applications with our own Thad Goodman from National Gypsum, which should be a great presentation. And keep your eye on your email, because that should be coming out soon. All right. I hope everybody's having a wonderful week and your fall and autumn is going really well and everyone's staying safe and healthy. And that being said, I'll see you all in a month. Have a great afternoon, guys.
Thank you, Catherine.
Thanks, Mark. Appreciate it very much.